In this video, we will solve a question that was asked by a person on Telegram. The question is like this. The demand and cost functions of a firm are being given as respectively as P is equal to 132 minus 8x is our demand function, where P is the price and x denotes the output, and total cost of the firm is being given as x cube minus 14x square plus 69x plus 128. We have to show that the competitive firm produces an output in the inelastic range of the demand curve, and also the monopolist produces output in the elastic range of the demand curve, and derive the deadweight loss in case of monopoly. Okay, so before I come to the question, let us see where does our elastic and inelastic demand lie. Okay, so if this is our demand curve, okay, let us say this is the midpoint of this demand curve. The upper half region denotes the region where we have what we call elastic demand. Okay, and this lower half region denotes our inelastic demand. Okay, so here elasticity of price elasticity of demand will be greater than 1, and here price elasticity of demand will be less than 1. Okay, so we have to show that the competitive firm produces output in the inelastic range of the demand curve. Okay, and how do we know what is elastic and what is inelastic? So in case of inelastic our price elasticity of demand, what we call the absolute value, should be less than 1 but greater than 0. Okay, if we get the price elasticity of demand between 0 and 1, okay, we say we are in the inelastic region. Okay, and if let me write it here, elastic region will be the region where our price elasticity of demand will be greater than 1 but less than infinity when we take the absolute value of price elasticity of demand. Okay, so we just need to prove that our price elasticity of demand in case of competitive firm will lie between 0 and 1, and in case of the monopoly it will be greater than 1, obviously. Okay, so let's go to the question straight. So we will come to the question. Now take the case of the perfect competition. We are being given the demand function and cost function. Let me rewrite it first. So we have P is equal to 132 minus 8x. Okay, this is our demand function. Our cost function is, let me write it here. Okay, so our total cost function is x cube minus 14x square plus 69x plus 128. This is our cost function. We are talking about the first part first. Okay, now in case of perfect competition, equilibrium occurs where price is equal to marginal cost. By price we mean the demand. Okay, by marginal cost we mean the supply. Okay, you know this stuff very well. So marginal cost is nothing but the supply curve in case of perfectly competitive firm, and price, which is demand function, so demand should be equal to supply. Okay, now we need to find out the marginal cost first. Okay, let me calculate it here, so it will get lengthy. That's why I am just trying to say the space here. Kya karo current. So marginal cost is nothing but derivative of total cost with respect to output, which is x. That means we take the derivative of this cost function with respect to x. Derivative of x cube is 3x square. Okay, I explained it n number of times. If we have x to the power n, its derivative will be n x to the power n minus 1. That is, if we have x to the power 6, 6 becomes coefficient, we have x 6 minus 1, that is 6 x to the power 5. Okay, if we have x to the power n, its derivative is simply this n becomes coefficient, and this exponent is subtracted by 1. Okay, so I will not go into further detail. Okay, so then the question will get very long. Okay, so 2 14s are 28x plus derivative of x is 1, we are left with 69, derivative of constant is 0. So this is our marginal cost. Now demand is equal to supply, means we have to equate this P with marginal cost. P is our 132 minus 8x. It should be equal to marginal cost, which is 3x square minus 28x plus 69. Okay, now solving this, so we have 3x square. Okay, then we have minus 28x, transposing this minus 8x, it will become plus 8x. Then we have plus 69 minus 132 is equal to 0. Okay, hey, it has 0 so 132 is equal to 0. Okay, at times the mistakes happen. Okay, now so we have 3x square minus 28 plus 8 is minus 20x. Now 69 minus 132, so 132 minus 69 go bah now the 2 minus 9 is now the bah, so this will come out to be 3. So so 63 this comes out to be. Okay, obviously this is minus, so we have minus 63 is equal to 0. Okay, we have a quadratic equation. How do we solve this question? Okay, if we have the quadratic equation, we will use the quadratic formula to solve this. Because we have coefficient of x square other than 1, so our x will be equal to, okay, minus b. Let us say this is our a, this is our b, this is our c. Okay, so we have the formula that is x is equal to minus b plus minus, you know this stuff very well, b square minus 4 into a into c divided by twice a. Okay, so in place of b we have minus 20, so minus we have minus into minus 20. Okay, plus minus, then we have b square, that means minus 20 square, then we have minus 4 into a is 3, then we have c is minus 63 divided by twice a. 2 into the value of a is 3. Okay, so this is 20 plus minus, so square of negative number is always positive, so this is 20 is 400, so minus minus is plus, so we got 4 3s are 12, 12 into 63. Okay, so we have 63 into 12, so this is 2 3s are 6, 2 6 are 12 again 12, so we have 3 6, this comes out to be 6, that is 5 7, I guess it is 756. Okay, so please, I know I'm just doing it manually, let us hope this calculation comes out to be right. Okay, so we got 756 here divided by, so this is 756, 2 3s are 6, which gives us, we have 20 plus minus 7 this is 1156 upon 6. Now 1156, it is root is, if we have 1156, how do we take the square root? Just make pairs from the units digits and use the formula. So we have 3 3s are 9, yet now the 2, here we have 5 and 6, they will come, so this gets doubled, so we have share. So 64 4 are 16, so let's solve it for 64 into 4 4 4 are 16, 4 6 are 24 25. Okay, so we got a perfect square here. Okay, so we got a 34, so we have 20, so under root of this comes out to be 34, so we have plus minus 34 upon 6. Okay, so we will get two values here, but 20 minus 34, if we get here 20 minus 34 upon 6, which will be a negative number, we will not require that very number, output cannot be negative. Then we have 20, because we got here two numbers, so 20 plus 34 upon 6, which is of course positive, so 4 go 4, 5, we got 6 6 7s are 6 8s are 48, 6 9s are, okay, So I guess it is 6 nines are okay. So for x we got two values, one which is minus 16 divided by 6, it is negative, we will not take this very value, but we got here another number which is positive, and we got x is equal to 9. Okay, so we got two values. I will write, when I solved this, I got the value of x is equal to 9. So x is equal to 9. Okay, when output is 9, what will be our price? Price will be equal to 130, hey, 132 here. So let me write it here. We have 132 minus 8, the value of x we put here. So this is 132 minus 8 nines are 63. Now what is 132 minus 63? So now, okay, 9 8s are, sorry, 9 8s are is 72. I have made another mistake here. So we have 132 minus 72. Doi goes yo. Yeah, so I guess it is 60. That means our price is equal to 60. Okay, so we got price and quantity in case of perfect competition. Let me also show it graphically here to make more sense what we are talking about. Okay, let us say this is our graph. On this axis we have the output, and on this axis we have the price. Okay, our demand function is this. When x is equal to 0, p is equal to 132. So let me show it here. This is our demand function. Okay, so intercept is 132. Supply function is marginal cost, and marginal cost is this. Okay, so it will be since it is quadratic one, it will be like this, but we will ignore this negative side here. Okay, so this will be our point of interest. So demand is this very stuff. Okay, this very function, and supply, which is marginal cost, will be like this. I will not show it in as a curved one. For the sake of simplicity, let us take it as straight one. Okay, so this is our supply, which is also marginal cost. Okay, equilibrium has occurred when demand was equal to supply, and what is the quantity being transacted at the intersection of demand and supply? That is 9. Okay, so we are producing 9 units corresponding to this. What is the price? So we got a price of 60. Okay, now the question was, show that perfect competitive firm produces output in the inelastic range of demand. Okay, so what we just need to see what is the elasticity of demand at this point. Okay, now how do we calculate the elasticity of demand? Elasticity of demand, the formula is price elasticity of demand is equal to, so let me rewrite this demand function first. Okay, so I know I don't have space here. Okay, so let me first save the space, or let me write it here. So how do we write elasticity of demand? Elasticity of demand will be equal to, so let me rewrite this first. So we have p is equal to 132 minus 8x. Let us solve it for x. So we have 8x is equal to 132 minus p. That gives us x will be equal to 132 upon 8. Okay, minus transposing this 1 upon 8p. This is our demand function. Now elasticity of demand is simply, elasticity of demand is the derivative of this demand function dx with respect to price into p upon x. Okay, dx upon dp means taking derivative of this function with respect to price. So derivative of constant is 0, derivative of p is 1. We are left with minus 1 upon 8. And what is the quantity, sorry, price, equilibrium price is 60. And what is x is equal to 9 in place of x. I hope you know this very relationship. It is very simple. If we solve this stuff, okay, so we have three threes are 9, so we have here 3 twos are 6, so we got here 20 divided by 8 threes are 24, so we got 20 divided by 24. It is an improper fraction. Okay, so I'm just taking the absolute value of price elasticity. So we got price elasticity of demand is 20 upon 24. Okay, I am not sure about the calculation, but it is an proper fraction. Okay, the value of this will be less than 1. And we have in the beginning of the season, this video, in the beginning of this video, told that the upper half denotes the elastic, this denotes the inelastic. Okay, we were told show that the competitive firm produces output in the inelastic range of demand. So we got elasticity of demand which is less than 1. Okay, so when elasticity of demand is less than 1, we say demand is inelastic. And we got the value of price elasticity of demand as less than 1. So we can easily say that the competitive firm produces output in the inelastic range of demand curve, because we got the price elasticity of demand for the competitive firm less than 1. Okay, when the elasticity of demand is less than 1, we say demand is inelastic. Okay, so this was about the perfect competition. Okay, so what about monopoly? Let's calculate the monopoly stuff also. Okay, so in case of monopoly, so second part is, I'm just trying to space, equilibrium condition requires that marginal revenue should be equal to marginal cost. Okay, marginal revenue, first we need to find out the marginal revenue. To find marginal revenue, we need to find out the total revenue, which is price into output. Price is this, so total revenue is equal to price is 132 minus 8x, to this we multiply x. Okay, so this comes out to be 132x minus 8x square. So this is our total revenue, and marginal revenue is simply the derivative of total revenue with respect to output. Taking derivative of this total revenue, derivative of x is 1, so we are left with 132. Derivative of x square is 2x, so 2 8s are 16x. This is our marginal revenue. Okay, marginal cost we have calculated it earlier, so just equate these two. So we have marginal revenue is 132 minus 16x. Let us equate it with marginal cost. So this is our marginal cost, that is 3x square minus 28x plus 69. Okay, now let's solve it again. So we have 3x square, then I can write it here. We have minus 28x, transposing this it will become plus 16x. Then we have plus 69 minus 132. Okay, uh, this comes out to be 3x square minus 8 plus shara daga shatu sato 8. So this is minus 12 x 69 minus 132. 69 minus 132 we calculated, it came out to be 63, which should be equal to 0. So now 3, so we can take 3 common. We have x square minus 3 4s are 12, so x minus here 3 2s are 6, 3 1s are 3 is equal to 0. Okay, so transposing this here, we get x square minus 4x minus 21 is equal to 0 divided by 3 is 0. Now we have the quadratic one, and it is a little bit easier than this. We can factor out here, because I can see I can here. Okay, So we should get sum of the two numbers should be equal to -4 and product of the same numbers should be equal to -21. Okay, let me guess. 7373. Yes, we can have -7, okay, plus 3. So -7 plus 3 is -4, -7 into 3 is -21. So I can write it like this: x square -7x plus 3x plus, in place of -21 I can write -7 into 3. So taking factors common, so taking x common here, we are left with x minus 7. Taking 3 common here, we are left with x minus 7 should be equal to 0. Okay, that gives us, taking x minus 7 again common, then we are left with x plus 3 should be equal to 0, which gives us either x minus 7 is equal to 0 or x plus 3 is equal to 0. If this is 0, that means x is equal to, transposing plus 7, we got positive quantity here, or in this case x is equal to -3. We will discard this negative quantity, we will not take the negative value here. So we got the value of x is equal to 7. Okay, now where will I write this? So I need to save the space, so let me write it here. The value of x, I got two values, positive and negative. Negative I have discarded because we cannot take the negative quantity, so I got the positive value. So let me rub this out here. So when I solved this stuff, I got x is equal to 7. Okay, x is equal to 7, so output is equal to 7. Now corresponding to this, what is the output? Output produced. Okay, so if quantity produced is 7, so what will be the price then? So just plug x is equal to 7 in demand function, that means p is equal to 132 minus 8 into 7. Now 132 minus 8 sevens are 56, I guess. Okay, yes, 7 sevens are 49, 7 8s are 56. Yes, so we have 56 6 okay, so I got 76 here. Okay, so it will be equal to 76. Okay, I forgot to draw the graph of this also. So we should have marginal revenue is equal to marginal cost. This is our total revenue. Okay, demand function is total revenue also. Marginal revenue is the derivative of total revenue, and it will have twice the slope of this demand curve. Okay, so let me use this very color here. This is our MR curve. Okay, so this is our MR curve, Mr. curve. Okay, so equilibrium occurs where marginal revenue and marginal cost curves intersect. I have told you supply function is nothing but the marginal cost. So let us see, this will be the equilibrium condition in case of monopoly. So monopoly is producing 7 units, less than the perfect competition, and corresponding to this, what is the price? We have calculated the price also, I guess, here. So price is equal to 76. Okay, now we are at this point. Monopoly output is this. This is the perfect competitive output. Now what is the elasticity of demand? At this point, as I have told you, we have to show that the monopolist produces output in the elastic range. Okay, so we should get elasticity of demand, greater than 1. So what is elasticity of demand? Let me write it here. Elasticity of demand, so we have calculated the demand function here. Okay, in the part first, so now dx upon dp, we got here -1 upon 8. Okay, so elasticity of demand in case of monopoly will be equal to, so elasticity of demand is dx upon dp into equilibrium price into output. Okay, so dx upon dp is -1 upon 8, and what is the price? In this case we have 76, and what is the output? output is 7. Okay, let's solve this. So 4, so let us check. 4 2s are 8. 4 2s are 8. So whether it is divisible by 4, let us see. 4 1s are 4. 5 6 7, I guess it is. Yes, it comes out to be 19. Okay, so we got it equal to minus 19 divided by 2 sevens are 14. Let's take the absolute value. If we take absolute value, we got 19 divided by 14 as price elasticity of demand. This is improper fraction. You can see it is greater than 1. Okay, this is greater than 1 because 14 ones are, it will be 1 point something. So as we have told earlier, that if this is demand function, let us say this is my midpoint, upper portion denotes the elastic portion, this is inelastic portion. Now how do we know this is elastic portion? This portion is elastic when elasticity of demand is greater than 1, and this is inelastic when elasticity of demand is less than 1. What we have seen in the perfect competition, we got elasticity of demand greater than 1. That means the monopolist produces output in the elastic range of demand curve. Okay, so this was about elasticity. Now let's derive the what we call the deadweight loss. Okay, so for this I need to rub this out. Okay, now what is deadweight loss? In simple terms, a deadweight loss means cost borne by society due to the market inefficiency. Okay, or in technical terms, we say it's simply deadweight loss is the loss of economic efficiency when optimal level of supply and demand are not achieved. Okay, so this point denotes our socially optimal output. Okay, so this is socially spelling में याद किया. I am really sorry for that. Socially optimal output. Okay, we need to find out that what we call mashti deadweight loss in case of monopoly. So in case of perfectly competitive market, we were producing 9 units of output at a price of 60. But in case of monopoly, we are producing at this point what we call the elastic region, and in this case we are only producing 7 units of output at the price of 76. So this is monopoly output. Okay, this is socially optimal output. As I told you, it is the loss of economic inefficiency when supply and demand are not at this point. Okay, so we are actually at this point when we are taking a monopoly into consideration. So monopoly output is less, price is high, and this is for society it is beneficial this point. But since we are at this point, we need to find out how much is the deadweight loss here. Okay, deadweight loss will be simply the intersection of these 3 points. Okay, this point, this point, and this point, where marginal revenue and marginal cost intersect, where demand and supply intersect. Okay, and where our monopoly prices. Okay, so the area of this triangle denotes the deadweight loss. Okay, this is the welfare, uh, you can say, which is being lost due to the market inefficiency. Okay, so our optimal point should have been this, but in case of monopoly we are only producing up to this, so this area will denote our deadweight loss. Okay, so loss will be for both producers and consumers. Okay, so we will have less producer surplus and also less consumer surplus here. Okay, how do we calculate this area? Now to calculate this area, we need another point, that is this point. Okay, so we need to find out this point. So this is a point where marginal revenue and marginal costs are intersecting. So let's take x is equal to 7 and put it into the marginal revenue function. What is our marginal revenue function? This. Okay, so we have marginal revenue when x is equal to 7 will be equal to 132 minus this is 16 into 7. Okay, this comes out to be 7 6 are 42, 7 1s are 7, 8 9 10 11. So 112 minus 132. So you can go as so this comes out to be 20. Okay, so just plug the value of x is equal to 7 either in marginal revenue function or in marginal cost function. So we put it in here, so we got 20. Now we will be able to calculate the dead weight loss. Okay, actually we have this triangle, and this triangle, what is the base of this triangle? 76 minus 20. Okay, obviously 76 minus 20, this very region. And what exactly is it? Let's calculate this. 76 minus 20 comes out to be, and obviously let me take this triangle here. So we have actually this triangle. I'm just taking this segment. Okay, so 76 minus 20, here we have 76, we have 20. Okay, and we have this, so this comes out to be Satan. What will be the length here? Satan is the point. So this is 56. And what is the height here? So height is up to this is, it is 7, here it is 9. So 9 minus 7 is 2. Okay, height is 2. Now dead weight loss in case of monopoly will be equal to 1/2 of base into altitude, what we call the perpendicular height, which is equal to 1/2 of, what is base? Base is 56. 56. And what is height? Height is 2. So this 2 and 2 gets cancelled. We got 56 as dead weight loss. Okay, so dead weight loss in case of monopoly will be 56. We just need to calculate the area of this very triangle. We use simple triangle formula, that is area of a triangle is 1/2 of base into height. So that's why we were required to find out this coordinate here. Okay, so let me recap how did we solve this question. So let me show it again. Let us say this is our demand curve. We were told show that the competitive firm produces output in the inelastic range. Okay, so if this is our demand curve, let us say this is midpoint. So the upper half region is our elastic region, and lower half region is inelastic. Okay, now when we have inelastic region, we say elasticity of demand is inelastic when elasticity of demand is greater than 0 but less than 1. And we obviously got elasticity of demand in case of perfect competition as we have calculated it, I don't remember now. Okay, so we got a number which was less than 1. And here we got, now by elastic demand, what we mean? We mean when our elasticity of demand lies between greater than 1 but less than infinity. And I am obviously taking the absolute value here. Okay, and simple, what we were required to see, we were required to see what is the elasticity at the equilibrium point of the competitive firm, and what is the elasticity of demand at the equilibrium point of the monopolist firm. Okay, so monopoly in simple words. Here we got elasticity of demand greater than 1. Here we got elasticity of demand less than 1. Okay, so we can say that competitive firm produces output in inelastic, and monopolist produces output in the elastic segment of the demand curve. And after that we were told to derive the loss, that is deadweight loss, the loss which is borne by the society due to the market inefficiency. And we calculated that came out to be taza yaad mujhe hai, that came out to be 56. Okay, so my mathematical calculations may be perfectly right. Okay, so some errors can occur at times, but about the theoretical interpretation that I give for this very question, so I'm not strong in the theory, and I don't know whether I have related the elastic inelastic uh, terms here absolutely right or not. So I will leave it for you people to decide whether I have done justice with this question or not. Okay, I hope I make myself clear in this video. Thank you. For more videos on mathematical economics, please subscribe this channel, like, comment and share also. Thank you.